Now that we know what classes and objects are, let's see how to use classes in processing. In order to use classes in processing, we have to follow 3 steps. Number 1 is to define a new type of data, which is to define a new class, such as we did with defining class student in the last example. Number 2 would be to declare and construct class variables, which is making new objects. And such as what we did with object Z, which was of type student. And third is to access data inside the class or inside the particular object that you make using the dot notation or the dot operator, which we are familiar with. So let's go through this and let's see a few examples so that it is clear for everybody. The syntax for defining a class is, as we showed, you would write class, which is a key term in processing, and then the name of the class. So this is going to be the name of your data type. So if you call this name, student, then the name of your data type would be student. And then of course you're going to have your data members. So for example, this class is called, whatever name is, name of class, contains data members, or they're also referred to as member variables, and they are different variable names, different identifiers. An example would be class student record. So this particular class has 7 data members. So the key term is data members here. And they're all publicly accessible. That means anywhere in your program, you could access these data members. This is discouraged and it's not the way object-oriented actually works, because object-oriented, you don't have access to all data members, but we're not really doing object-oriented, so we have public access to all of this. I know what I just said seems a little abstract, but it's going to make more sense as we go on, and especially if you go into object orientation. For the time being, we can access all these variables from anywhere in the program. Very, very important note here. When you define a class, you're just telling the computer, look, you have types like int, double, float, and I'm going to introduce this new type called student record that has a whole bunch of other variables inside. So nothing is actually loaded into memory. Just like because you haven't declared a variable yet. All right. So an example would be, if you have setup, you would have a class called name data. It has 3 different data members: student, first name, student, and you have first name, middle initial, and last name. And of course, we don't initialize these variables here, right? That's one thing that you have to understand, is that we don't initialize any of these variables here. Processing does allow the initialization of variables here, but that's a big no-no. So what I'm asking in terms of object orientation, so I'm asking that you don't initialize any variables inside the class itself. Class definitions typically go at the top of your program for organization purposes. I mean, you could put it at the bottom of the program, it still works. Or it's a good idea to put it in other tabs. So when you program in processing, you have multiple tabs. It's a good idea to put your class definition in other tabs, and then so that your program doesn't get too long. It's a good practice to name, for example, say class name data on top of the tab, and then the class would be inside of that tab, and have almost like a different tab for every class. It's a really good organized way to do it, unless you have a lot of classes, and then you can put them together. Step 2 is to declare class variables, and actually this is to declare and construct. So I'm actually going to add this to my slides. To declare and construct class variables. So inside of setup, this is going to be a local variable to set up, or we could define it as a global if we want it to be used by draw. But we declare a variable, so that's the new type. That's the new type that we have made up here. This is name or identifier of the object. Actually, I should write it this way. This is basically name is the object. Here we are constructing the object. So remember, in this side we are declaring. Here we are constructing object. Here we were declaring object. And I said this is called the default constructor. The default constructor constructs the object in memory and it initializes all the data members. So let's look at part 3. Part 3 is we can access data members inside the object using the dot operator. So let's draw the memory diagram. I'm just going to draw it here. Let's draw the memory diagram for setup. So, and of course the class definition is up here. So when the class definition is up there, nothing is loaded onto memory. We start setup and we have an object name, so it's declared, so it's in memory. And then we're going to actually construct the object. So we're going to construct the object like so. And inside of that object, if you recall, if we go back, we have first name, middle initial, and last name. And basically, so first name, we have middle initial and last name. And so first name, they're all null, and middle initial is basically set to 0 because it initializes things. Then you say name dot first name, just like it is the case with the arrays. This is the case of finding addresses. So it says, okay, first name dot, so name is here, dot first name, it's this guy here, and you need to initialize that to Sam. So it's going to construct a string named Sam, which you have 0, 1, and 2 indices. Middle last name is Smith, so it goes to last name and it initializes last name to Smith. And middle initial to S, so S goes in here. Now, if I went like this, if I said print ln first name, what happens? Well, what is going to be printed? Well, nothing is going to be printed, right? Because in setup, there is no such a thing as first name. You have name and then you have first name. So it's like, if you look at let's say if everything is put away in the kitchen, you go get a cup, you won't find a cup in the kitchen unless you open the cabinet. So it's the same thing here. So this is wrong. This is an error. If you wanted to print first name, you would have to say print ln name dot first name. So this gives an address. This says, okay, go to name, open up name, go inside, and then there's gonna be first name and print that, and that's gonna print it. If I just want to print, let's say M at the end, that guy right there. If I want to print that, what would I write? I would say print name dot first name dot char at, and that is index 0, 1, 2. This is going to print out M for us, right? So it's all about knowing how to find that address in memory, and looking at the memory diagram and knowing the dot operator, then you should all be able to do that. So you have, in order to access, to summarize, in order to get access to any data members, you need the object name, not the class name, right? The object name, because if there's nothing in class. Class is a type, right? Class is a type. Just like in memory, if you say int a, in memory you're gonna have a, right? You're not gonna have int. So if you have a class student, like we did before, if I say student S, so in memory you're gonna have S, you're not gonna have student. So if you say, so class was like this, right? It was class student, let's just say int ID and int age. If this is our class and I say student S is gonna contain ID inside of which is 0, because it's automatically so this should say new student, and you're gonna have age, and age is gonna have 0 inside. So notice that you don't have student in memory, just like you don't have int in memory. You have S, which is the object, and you have A, which is the integer. You don't have the types in memory, you actually have the variables in memory. So if I said print student dot ID, that's really silly, right? Because student is the type. This is just like saying if I said print int, like that's just not possible, right? So basically you won't write the name of the class here, but you would say print s.id, so the actual object. So that should be clear to everybody.